My name is Fabrice Desré. I've been working on web tech for probably way too long now, but I cannot stop. So I'm gonna talk to you about Capyloon, which is, as Desré said, is a project about a mobile web OS and how we try to make things differently using decentralized web techniques. So yeah, Capyloon at the base is it's a descendant of the work that was done on Firefox OS and KaiOS, and it's a very user-centric mobile web OS and a way to experiment with new techniques coming from the decentralized web community. So mostly IPFS, decentralized identity, UCANs. A very, very central point for me was to bring back user agency in a mobile web operating system. And so we're starting to work on that earlier this year. We have builds available for a few different platforms, some Android devices, Pixel 3a, some generic images for Android 10 based devices, and we're working on newer devices, the Pixel 6a. It's quite ironic that the devices that are easier to work with are the one from Google, but that's what it is. We also have builds for Linux phones, like the Pine phone and the Librem 5. So these ones are a bit more like nerdy and more for hackers, but they're very important, I think, to support this project that try to bring more openness on the hardware side and getting better upstream support for all these open devices. We also have a desktop simulator, so it's very useful when you work on the front-end side. Like all the apps that run on this OS are web-based, so it's just web apps with sometimes additional APIs compared to a regular browser, but you can just debug them with regular dev tools. Here it's Gecko based, so you use Firefox DevTools and it just works. It's pretty neat. One thing that we don't try to do is be very similar to existing OSs. That would make no sense. You cannot anyway compete on the same in the same space exactly. So we really try to not do that, and we try to address a few issues that we've seen both on the mobile OS space and in the web itself. So one big problem with mobile OSs is that everything is tied to the app stores, and how they centralize a huge amount of control just because of these app stores. And they're supposed to be general computing devices like an iPhone or a recent Android device. It's pretty powerful. But actually you cannot do much with that. And in the 80s in France, we had something called the Minitel, which was a very nice device for the time. It was in the 80s. So the state-run telco was giving away these devices that looked like BBS terminals, and you could access a bunch of services from there. And so the carrier was running everything. It was giving the devices, it was letting service providers hook up services, and was providing discovery through some directory, and it was managing payments because you were basically billed on your phone bill. And that's exactly what's happening with app stores right now. Apple and Google are controlling what apps you can run on your device. They control, depending on your country, what you can do. Like, oh, you're in that country, no VPN for you. Too bad. They control all the discovery. You have only access to the store itself to find new apps. Compare that to the web, where you have a bunch of different search engines. Especially now, we can see that there are new ones coming up. We've seen the Brave search engine, which is pretty good. There are others like Niva, Kagi. There's a bunch of choice now. And yeah, they control payment through in-app payments and so on. So that's very surprising for me. We're supposed to have much better computing devices, and we are back into to a model which is something very, very backward to me, like in the 80s. Then we have some lessons that we can learn from the HTTP web. It's not a criticism of how it was designed and built in the early 90s, because we didn't know better, but it was not designed to prevent centralization by a few big players. Like, yes, sure, you can spin up your own HTTP server, it's not that hard. Well, it's a bit cumbersome, but it's doable. But nothing was preventing big players from getting all the network effects and being very dominant. There's nothing also that helps with data portability, so that you can move your data from one service to another. You're expected to rely on all these services providing you APIs to do that. Like if you want to move from Flickr to another photo provider, it's not necessarily easy. But not everything is bad on the web. It's still the best permissionless platform we have. It's still very easy to publish. You can create. No one is going to censor you and so on. And it's a very solid foundation. Security model is what it is. It's not perfect. Not everyone likes it. But the same origin policy and content security policy, for instance, are pretty solid foundation to build on top of. Yeah. What can we take from the decentralized web to help us? First, we have data portability by design, because once you have content-based addressing, well, it's all there. You don't need to worry about who's really hosting or created your data, as long as you know the address. We still have links. As long as we have URLs, we are good. We have links, we can navigate, we can create this web of data. Okay, and with decentralized identity and UCANs that are ways to create a delegation model of capabilities, so you can express who can do some actions based on some data. It's a very interesting way to think about how we can grant permissions to services or other identities in a way that is much more powerful than the current permission model that we use on browsers. So in Capyloon, we have implemented UCAN support for some of our APIs, and here I have a few screenshots about how it looks when you try to access the navigation history of the user. So the app here will request access. And the next step is that the user is prompted to say, okay, do you want to let this application access my navigation history, and for how long we grant that access? So we can really control if we want to do a very short session, or if we want to grant it for a much longer time. And once it is granted, the application can just use the API, basically pass the UCAN that was created and get access to the API. So it's very interesting in terms of flexibility and how that can make that discoverable and transferable. So in Capyloon, I'm going to describe a bit what we've done to do IPFS integration and where we started and where we are now, what we plan to do next. So initially we just started with fairly simple protocol handling for IPFS and IPNS, and we did that using a remote HTTP gateway, meaning that behind the scenes the protocol handler was just redirecting to a gateway and trusting the gateway. Okay. So that's pretty much what Javier showed for Chrome. It was very similar. I think the only difference is that in Gecko, once you have the protocol handler implemented, you can use it anywhere, not just on top-level navigation, but in Fetch, in anywhere you can put an URL, it works. And so we implemented that, and we implemented uploads to Filecoin using estuary. So you could, here, that was during the last IPFS conference, took a photograph of the stage. You decide to publish to IPFS. You can optionally put a password to protect your file, and it gets uploaded. So we get a UI with progress upload, and then you can share using QR code, for instance. So that's publishing using Estuary, so they have their own API that you can use for that. So it's a bit different from what Mauve has presented with aggregor publishing, but we're gonna at some point we're gonna get something compatible. So that was really what we started with, and now we have something much better that we published the latest build about a few weeks ago. We wanted to get verifiability of the data that we were fetching, and for that we integrated a full IPFS node on the device. Since we have control over the full stack, we can do that in a way that is not possible right now on iOS or Android, where you are limited in terms of how long you can run processes. So we took Airo. We've been collaborating with the team at Airo that shipped their first version yesterday. And so we did two main contributions. One is that instead of using the microservice approach of Airo with different processes, one for peer-to-peer, one for store, one for the gateway, we are bundling everything in a single process. And the other thing is that since on mobile we cannot really afford to run the peer-to-peer discovery and the DHT, we added a feature where we could raise the peer-to-peer stack with raw access from a gateway, the kind of access that Lydell described earlier. And so once we had that, we just disabled the peer-to-peer stack. It means we just get all the resolving that is fetching raw content from the gateway and doing all the verification and all the decoding. So now we switch from having to trust a remote gateway to fetching from our local node, and we know that we can trust it because it's doing all the decoding, all the data integrity verification. Okay, and technically it's using HTTP over a Unix domain socket, so it's a bit more secure than doing plain HTTP over TCP, and it also helps with some Gecko internals where we expect some HTTP channel for caching and so on. In terms of resource usage, I'm pretty surprised that it's really using very little memory. That's a good surprise. So we can see here the highlighted line is the IPFS daemon running. And the memory, you need to look at the RSS column, so it's less than 23 megabytes, so it's very, very low, actually. CPU usage is still a bit high. That's gonna improve, but so far it's a very good start. I think it shows that you can actually have a full node, all the guarantees that you get from a full node running on a mobile device. And it provides you offline support, of course, even if your network is done. So what we plan to do next, we have a few things in the pipeline, a bunch of improvement on the Airo side, like we want to be able to configure the network, all the network stack used by Airo, depending on the connectivity context of the device. Like you don't want to do the same thing if you're using LTE versus a Wi-Fi connection. And even on Wi-Fi, it can even be different if you're in your home network versus a guest network that you're somewhere else. We want also to experiment with different peer-to-peer topologies, different configurations around that. It's probably okay to do MDNS, for instance, in some settings, and not DHT. And one important thing is that we want to know what kind of new APIs we have to expose to web content to let people write distributed web apps very easily. So the first step, is to be able to get and post content. So right now we have all the get is covered by the protocol handlers. Publishing, that's what Mauve did in Egregore. We need to discuss to agree on something that we are all happy with. And there are other things like Pierce Discovery API, custom PHP protocols. I know that that's something that the Bertie team will need if we wanted to do a port of Bertie on Capyloon. There may be some other APIs needed. I'm not sure which ones. I'm looking for inputs from app developers. So if you want to come and provide inputs, they're more than welcome. Another thing we're going to work on is web native file system support. So web native file system, it's like a much better UnixFS. It supports not just basic hierarchical storage, but there's public and private trees, so you can share stuff privately, metadata, versioning, etc. It's mostly worked on by the people at Fission. And what we plan to do with that is that we have in Capyloon all the user data is stored in a virtual file system, so like all the user media, contacts, even we are gonna store various WASM plugins for instance image processing and things like that. The idea is that instead of only storing locally and doing some custom backup, we can publish all that to IPFS through WinFS. And it meshes well with IROs because WinFS just needs a block store as an external API. So we're going to hook up a native file system with IROs block store, and we should get a fairly complete solution that is providing us with backup restore capabilities and being able to also do cross-device access to the same data. As more like future work, something that I really like to explore is something around device convergence using IPFS. I'm very often in situations where I want to access or control same kind of data from different devices. Typically at home, you have laptop, a phone, a media center connected to your TV, and it's kind of cumbersome to get all that work well together. It should be seen as kind of a single virtual device that has access to your data, or that you can maybe share some data with other people in the same space. And I think with all these techniques, we can get to something that just works in a very seamless way and very privately. So it's something it's a bit further thinking, but we should try to do something around that. Guest access with UCANs also, it looks fairly good use case for UCANs where someone won't access some very specific subset of your data. It's something we can do. And that's what I have. Thank you, everyone. And if you want to see it running, I have a couple of devices and I can showcase. The networking is not helping much, but I can still try. Thank you.